Hello and welcome back to the channel. Today I want to talk about some things that are not necessarily related to unit testing. I realized that I started this whole prospect about unit testing and whatnot, and today that's not what I want to talk about. What I do want to talk about, what is important, is well, I have a new client and I pulled the client's database down into a project similar to my AdventureWorks project here, and I started looking through the code and the things that they have going on inside of the code. So first thing I'm going to do is take a peek here at a stored procedure that came out of the box with the AdventureWorks database. So this may not be the best one. So this creates a recursion downward to create a build of materials through getting a build of materials. So get employee managers is also recursive, which is great. Log an error, print an error. Okay, so this type of stuff. So this is important. So the print command, right? The print keyword takes a parameter where it prints it prints a message, right? And if you notice here where it's casting to variable character of of a maximum length of 5, right? It's converting that error line, right? An error procedure, error state, blah blah blah. So you could call this, from someplace and say, printer error, what have you, right? Print the error about the information about the error that caused the execution to jump to a catch block, right? So that's really what this does. So you would embed this inside of a catch block and go from there, right? So it should be executed from within the scope of a catch block. Otherwise, it will return without printing any error information. So that's totally fine, and it prints it in the messages of a query. I'm gonna start a fresh store procedure here. So actually, I think I'll just start a fresh SQL statement. So let me work on it this way. Okay, so I'm hooked up to the AdventureWorks database, and I want to write a basic statement to power a screen somewhere and talk and get I don't know, addresses that are of a type for let's see, let me get this data again. That is home addresses. So I want to see all the home addresses for people inside of addresses. How do I do that, and how do I make it look right? Now, you're going to see that address is blue because address is a keyword inside of SQL. So I take that keyword and I bracket it in. So by doing that, the SQL engine knows that now address is an object. It knows that person.address, it should look for that as an object, right? And because I wanted everybody that had an address type of home, right, I would say inner join person dot address type, and we'll call that Pat. Do we not have address type on person address? Apparently not. Person.person. Business entity. We do have business entity address. That goes back to the address ID and the business entity ID. So apparently person.person doesn't necessarily mean person unless person type. Let's see. we've got person type here. Well, let's take a look at what data is in that table. So we have person type EM. Let's back up and do a quick query out of here. And this is all part of discovering what's in a database that you may have just inherited. So I want to know what all my person types are, right? And you wouldn't necessarily use the distinct keyword on normal stuff. Person.person. Right, so this is going to give me all of those distinct values. So IN, EM, SP, SC, VC, or GC. And I really have no idea what that means. I think EM might be, I don't know, employee. Hard to say. So we've got human resources.employee. That business entity ID, login ID, organization level, job title, birth date, gender. How do we know who this person is? National ID number, login ID. We have login ID down there. Nope. We don't. And this is starting to make less and less sense. However, let's go back to talking about the important stuff that we need to talk about real quick. If I just want to do a query against person address and I don't necessarily care about pretty much anything other than, you know, getting some information out. So I could do this, right? I could say select all, right? Select star from that. But here's what happens. Tables get changed over time, right? Stuff gets added or subtracted from a table over a period of time. So you can't really power an application from a select star. So here's what you really do is you go through every column that you may want out. And let's say, for example, you know that you're looking for things inside of the United States. So province ID really doesn't make any sense. What I'm seeing is this, is I'll see somebody that tries to alias a column like this as state, right? State ID. This is wrong. This is wrong. Why is this wrong? Well, SQL thinks that this is a string. And it thinks that it's an ASCII string. It will work, right? If I execute this, it will work. It will say state ID. Okay, fine. But at the same time, it's wrong. If you're going to alias a column, tell SQL that this is the new object. So it knows that this is an object because it found it, it can resolve it, right? Tell SQL that this is an object, and the as keyword is actually optional. So you can do this. That works. And it actually works. It's better for the query engine to do it this way because you're telling it, hey, this is just the new name of this object, instead of trying to let it assume the casting of a string is your current object. Hopefully that makes sense, right? So let's talk real quick about objects and strings. So objects are tables, columns, indexes, functions, user-defined types. Those are all objects inside of a SQL database. This is an example of a Unicode string. So you're telling SQL, I'm going to say, okay, so what have I done here? I've declared a type here that is a Unicode string of Unicode type, which is nvarchar, right? Some people call it nvarchar, some people call it, Unicode 50, some people call it whatever you want. But this is what it's called inside a SQL Server. This is how to tell it that you have a Unicode string. And then when you want to reference a Unicode string, that n needs to be in front of the string. So it will do it. Like the SQL engine will do this for you. So I'm going to get rid of that. So let's say I cast that out and I say set Unicode string equal to ABC123, right? And then I select my Unicode string, and notice I set that as a type, as an actual object. So it should recognize this as an object and not have to do an implicit conversion behind the scenes. So there's my message, right? ABC123. Fine. So what happened behind the scenes? Let's look at the query plan and see the message as it goes. Okay, so we've got a Unicode string here. We're setting the Unicode string equals ABC123, and it's doing a simple assignment. And then a select back out. But what it's actually doing is an implicit conversion back out to it. So let's say I didn't want to do this. Let's say I wanted to cast, I don't know, an integer value as a Unicode string. Now it's probably going to give me an error, but it won't. Well, why didn't it? Because it sees a 0 as a 0. Where'd my results go? SQL command mode, include actual execution plan. I've never tried to do it inside of SQL Server, inside of Visual Studio before, but it clearly is not pulling in my actual execution plan. So I'm going to go over here to a new query window with SQL Management Studio. I'm going to post this in, and I'm going to say include the actual execution plan, and then I'm going to run that. Where's my execution plan? But what it's doing is it's doing an implicit conversion from the actual 0 to a Unicode string. And it's going to do it again. So it cast this implicitly as a Unicode string. So you can look up the cast and convert types that will do implicit conversions and some that won't. That's really, really important. It's really, really important to understand that that is a denotation of a string. That is the denotation of a string. That is nothing, right? Double quote, double quote. So unlike C#, that's really nothing. And comments either start like that, right? And that's a comment on a single line. And this is a comment on many lines, right? So these things are really, really important to get right. You don't want to have 50 lines that are made up of single line comments, right? Use a block. You don't want to have implicit conversions between Unicode and non-Unicode strings. So let's say title. So if we look at person.person, and let's just look at the unique titles, okay? And get, because title is Unicode 8. So let's look at a Unicode 8 title. Okay. So cool, Sir, Mrs., SRA, I don't know what that is. Miss, period, Miss without a period, and Mr., period. Interesting. Okay, so now we have those particular bits of information. Let's figure out and decide how if we needed to query and get all of the people that were in this table that had a title that was, I don't know, Mr. What's the best way to do that, and what are some other ways to do that? So my opinion is the best way to do that is to create a variable of the same length and type that is the column that you want to select out of. Now we're going to change this a couple of times, and I'll show you what can happen. And let's see, do we have, why is this thing so bad? Let's go over here and look. Do we have a person? Do we have an index on anything? Last name, first name, middle name that's non-clustered, the row GUI that's non-clustered. Person, business entity ID, person demographics. Okay. So first thing I want to do is I'm going to add an index here that is a non-clustered index. This just is a normal index, okay? And I'm going to call it table name person. I'm going to call it person title. And I'm going to add a key column that is title. And I want to, because I'm going to pull some other columns out, I want to not have to do, you know what, I'm going to demonstrate that too. Okay, so this is just going to have the title as an ascending nvarchar 8. Now, why does it have a 16 here in the size? Well, it has a 16 in the size because Unicode is a 2 byte per character representation. whereas ASCII is a 1 byte per character representation. So because it has 2 bytes, it can store inges and umlauts and accents and non-ASCII characters, Asian characters, some Cyrillic characters, that sort of stuff. That's all Unicode, right? And the way that SQL Server stores that is 2 bytes per character. So you see invoke 8, the size is 16. So now there is and I'm going to type it correctly, right? So I've denoted this with a large N, right? And I'm going to say select all just for demo purposes. All right, where title equals title. Hopefully that makes good sense. Now I'm gonna leave that first query up there. I'm gonna separate those batches with a go statement, and I'm gonna say, all right, so I got all this stuff, which is great. I'm gonna run this again. All right, so here's my execution plan. I notice I have an index seek, and because I have an index seek, it's going to go right to those rows that match the data that I'm looking for. So if you look here, it says number of rows read 577, actual number of rows read for all executions 577, right? Number of executions 1, estimated operator cost 0.03467, which is 1%. So I know, because I've typed all of this correctly, use the correct data types, and you can see down in the bottom the search predicate, search keys, prefix adventureworks.person.person.title equals scalar operator at title. Okay, so the other thing you see here is a key lookup. Because I was getting all the rest of the data, once it found the bits that I needed inside of the index, at that point, it could go through and look up in the table the rest of the data that we needed, because it stores that bit, right? Just that bit that's in the index. If we want to get rid of the key lookup, we have to do the best thing to do anyway is an include as part of your index. So this is super important. So let's take a look at this. If I was to cast this out as a non-Unicode, right, as ASCII. So what I'm asking it to do is an implicit conversion between an ASCII character to a Unicode character set and find me the same string. Now in this case, it did an index seek again. But look at the seek predicate down in the bottom. It says convert implicit nvarchar 8 title 0. So I'm going to freeze that, and I'm going to take a screenshot of this thing. As I take a screenshot of it, hoping it's going to screenshot properly and I can display it. But that's super important. That implicit conversion that's going on down there takes extra cycles. Now, how do we see those cycles? Where are we going to see those cycles? So, well, I got to remember the command here. So, I can't remember it off the top of my head. There is a way to see the query statistics, and I will find it real quick. Set statistics IO on. And then you can also say set statistics time on. And now that I have both of those on, as I execute this, and I also get the execution plan, it's going to give me some information. It's going to tell me that the table person scan count is 1, logical reads 1779, physical reads 0. Physical reads 0. Now, why did it do that? There's no physical reads of the table? Well, no, it doesn't have to. It doesn't have to do physical reads of the table because it has an index. So it's doing logical reads. Okay? And if you look at the execution plan, we still haven't changed anything. We still have that implicit conversion. But let's look at the total elapsed time, right, of 190 milliseconds that's down here. So let's change this to not need its implicit conversion. And see if we see a difference. So the logical reads is the same. There's still no physical reads. And because I changed it, so we lost 8 milliseconds. We run it again. And keep in mind that when we run queries, we run them again and again and again and again and again. And if you have a if you're doing these implicit conversions on a regular basis, see, now we don't see the implicit conversion down there in the seek predicate, but we do still see the key lookup. So let's say we want first name, last name. What other values do we want? And I don't want additional contact info. I'm not going to mess with the XML columns at this stage of the game. But so let's say we just want first name and last name. That's perfect, right? We just want first name and last name from this, and then let's look at it. Let's see what we get. There's our first name and last name. That's great. Our actual total elapsed time went down, which is good. But you see here on the actual table, we have 108 logical reads, which is good. It's down. But we have a physical read, and we have 103 read aheads. Okay? So in our actual execution plan, we have an index seek, and then we have an index scan. And if you look at the number of rows read here as part of the index scan, 19,972. Why do we have an index scan? What's it doing? So let's look down at the object, right? It says IX person first name, last name, first name, middle name. So it's actually scanning another index to best find that data. And that might be good and it might be bad. But let's talk about how to get rid of that index scan and make this thing actually run that much better. Okay? So I'm going to go back over here to SQL, and I'm going to look at my person title. I'm going to go into properties and take a look at it, and I want to add my first name and my last name because those are the 2 bits of data that I want, that I'm selecting out as part of my query. So it recreated the index for me. That's all done and happy. Okay? Now let's take a look at this particular query and see what happens. So we're down to 141. It got rid of 2 prepping counts as parts of the tables. And if we look at the execution plan, we just have an index seek, because the data that we were looking for was included as part of the index, and it was just able to put it out. So you see the output list down below in the query plan. It's outputting person.firstname, and person.last name from that seek predicate that's going on. These little things are all the things that add up in making your queries fast or slow, because you want your cache hit ratio to be extremely high, around 85 to 90%. And that really means that 85 to 90% of the time, the queries that are being executed against your database are part of that cache. Right? They're already in memory, they're ready to go, the execution plans are loaded up, and it's just running them and doing the best it can. You also see in this particular index seek that number of rows read is back down to 577. We're not scanning 19,000 rows anymore. That's huge. That's huge. So I hope you learned something from this about optimizing your where clauses by using appropriate data types. So and how to use Unicode and non-Unicode as part of running and creating queries. Also, when to use includes in indexes and when not to. Yeah, this has been. These are very common problems when people that don't write SQL all the time scratch out SQL and say, "Oh, it works. We're good." Okay, it works, but we were looking at 190 milliseconds sometimes, or 200, and now we're down to 141. Right? We had one scan. We had 3 total scan counts. Now we're down to 1, with 6 logical reads and no physical reads. So you can see here the reality that is optimizing your SQL, and it's very simple, and it's also very subtle. So good luck. If you have questions, please write down in the comments that you have questions. I'll try and answer them as best I can. If I can't answer them in the comments, then I will create another video and do my best to answer your question. Thanks. Have a good day.